Hello, this is Mr. Harris covering page 16. This is the video where we are going to derive the quadratic equation a la Al-Khwarizmi. That's why we call it algebra, if you will. Al-Khwarizmi, I don't know. I've always heard it as Al-Khwarizmi. Died 850 AD, Baghdad, Iraq. You had a wellspring of knowledge throughout Turkey, all those guys with the Sumerians and all of that, transferred to Egypt and Greece and Iraq and back to the Middle East again. And this is sort of what someone typed up of his actual notes that were written in Arabic. So thankfully to a lot of the Islamic scholars, we didn't lose a lot of that knowledge. They preserved it, and not only did they preserve it, they expounded upon it. That's one of the great traits of humankind is you don't have to constantly reinvent the wheel. We pass knowledge on and we constantly build on previous generations. Thankfully, we know how to balance, or we know what the quadratic equation is. So the most obvious example is if we're doing ballistics from cannons, bam, boom, bing, all that good stuff. This would be one route, that would be the other route. There's a lot of other applications in terms of calculating area needed for spaces, all that good stuff. Down to satellite dishes even. We need to know the quadratic equation before we can figure out the focus of a parabola. So we are going to derive the quadratic equation in a similar fashion as Al-Khwarizmi created his own derivation, discovered his own derivation by completing the square. Muhammad ibn Musa al-Khwarizmi, influenced by this. If you're curious, do try to take an art history course in college. The learning never stops. Let me get my pad and just begin the process. Of course, I had to run through it myself to make sure all the kinks were worked out. I tried it here and it didn't work out, so I'm going to try it again. Okay, so thank you, Al-Khwarizmi. So we're starting off with the equation y equals ax squared plus bx plus c. And we're going to get the quadratic equation, a very efficient way of solving quadratics. I'll leave Al-Khwarizmi up here for moral support at the top. And let it focus. Okay, so beginning the process of completing the square, the first thing we have to do is we got to turn a into 1. So let's just divide everything by a. Then we'll have y divided by a equals x squared plus bx over a. I'm going to leave a gap there, plus c over a. And I'm going to go ahead and complete my square, b divided by 2a squared. So right here, I'm going to interject b divided by 2a squared. And this is essentially what Al-Khwarizmi did. He took this notion and then he tested it to see if it would work out. So this should be a complete trinomial. So we can now write it like this: x plus b over 2a squared. So it's going to be this x plus that plus c over a here. And I'm just going to test this out. I'm going to FOIL this out to see if I FOIL this out, do I in fact get this? This times this plus this should yield that in a weird way. But let's see if it works out. Okay. Khwarizmi's off in the distance, but I need to focus. So we're going to go here. Okay. So let's just do x plus b over 2a, x plus b over 2a, f o I l. And when we add these two, we get x squared plus 2xb over 2a plus b over 2a squared. And yes, we are left with bx over a, xb over a, bx over a. So that is a perfect square trinomial. We can definitely work with this because we know it works out. This is the same thing as this. So the first step is we're going to set it equal to y. And then in step B, we're going to replace y with 0. And then eventually we're going to get, this is the step where we actually derive the quadratic equation, and we're going to do the vertex form and all that stuff. So let's first off, after we check to make sure it's correct, let's go ahead and solve it for y. We will get y equals multiplying everything times a, x plus b divided by 2a squared plus, now when I'm multiplying everything by a, something should be happening. I hope you caught this. I just caught it. And this is the funny thing with derivations. You learn the ins and outs of why things are. Remember when we previously completed the square? We added this, but how dare I just add something here? I have to also add it here, right? So if I'm going to just take liberties to keep the seesaw balance here, I have to also add this here. So it's going to be plus b divided by 2a squared. Because you can see now it's not going to work out, because remember, every algebraic equation is the seesaw. If I'm going to just throw something on this end, I got to do the same thing here. And technically speaking, if I'm multiplying everything by a, I would have had to also multiply this by a. So if I'm multiplying every single thing by a, I would have this times a plus c divided by a times a just gives us c. And then it would be minus a times b divided by 2a squared. I'm going to put this on hold, and I'm going to try my best to combine and add these now. And so we have y equals a times x plus b over 2a squared plus Mr. Seeking One to the rescue. But before I do that, let me clean this up a little bit. Plus c minus a times, that's actually b squared divided by 4a squared. I'm squaring everything. So in order to combine these, Mr. Sneaky One to the rescue, it's going to have to be 4a squared divided by 4a squared, just so we can combine them in some way, shape, or form. Okay. So this is the first step. I can combine these if I want to, but it's not completely necessary. The next step we're going to do is we're actually going to set it equal to 0. So this is what we would need for step A. Now jumping to step B, where it says set it equal to 0. Again, this is page 16. We're going to replace y with 0. Because we're looking for the zeros. Okay. Several things we can do. One thing I'm going to do is I'm going to add this to both sides. I'm going to go ahead and combine these and then send this over. I think that's what I'm going to do. Actually, it'll be easier to add this to both sides. 0 plus that, so we have ab squared divided by 4a squared minus 4a squared c over 4a squared equals a times x plus b over 2a squared. Okay, so let's see what else we can do. Let's see what else. It's like solving puzzles. I could simplify, but simplifying may not give me exactly what I want. Hmm. If I simply divide everything out by a, maybe it'll give me what I want, maybe it won't. We have to see. I'm going to clean this up. I know we changed it to add it, but I'm going to clean it up slightly because the next step is we have to divide by a, and then we're going to take the square root. So I have b squared divided by 4a minus c, and we're going to multiply everything by 1 over a equals x plus b over 2a squared. So we are left with, again, b squared divided by 4a squared minus c divided by a equals x plus b over 2a squared. Again, Al-Khwarizmi, he died in 850 AD. Thanks to him, we have the quadratic equation, and this is how he came up with the quadratic equation. A lot of the knowledge that the Middle Eastern scholars derived was then transferred onto Timbuktu in northern and central Africa, connected to Mali. And that knowledge was further um, developed, all while Europe was still in the Dark Ages. And then you have the Renaissance. It's fascinating learning the history of math. Let's continue on. I'm going to now take the square root of both sides. Before I do that, this probably won't really work the way we need it to. I don't want to take the square root with that involved. So we're going to have to change this once again. So 4a squared. So here I go again with this 4a squared. And I'm going to combine these just to make the square root easier. So we have b squared minus 4ac. You can already see it forming. And we're going to take the square root of that and the square root of that. This leaves us with x plus b over 2a. Look at that, look at that. Isn't it fascinating? It's like cooking stuff up in a lab almost, except with numbers. No, I'm gonna save the quadratic rap song for when we're done, because you can already see it forming now. We're essentially done. Cleaning this up, we have the square roots of b squared minus 4ac divided by square root of 4 is 2, square root of a squared is a. I'm going to go ahead and subtract b over 2a from both sides. And there you have it. That's the quadratic equation. 2a hang low under negative b. I made a mistake, but I'll fix that. Plus or minus square root b squared minus 4ac. If you practice your quadratics, learning automatic, all that good stuff. Remember, shame on me, when you take the square root on one side, it has to be plus or minus that. It has to be plus or minus that. So that's why it's negative b over 2a, because we had to subtract this from both sides. We can rewrite this as, they're both divided by 2a, so we can combine them as negative b plus or minus square root b squared minus 4ac all over 2a. And that's how we find the solutions to quadratics, any quadratic, even imaginary quadratics. Hooray, hooray. There were some hairy moments. There were some moments where I could have completely lost my way, but I reminded the pattern, the procedure. Shout out to Al Khwarizmi, he was with us and all that. Again, this is my first attempt, and I'm like, I need to go practice this because it's a bit hairy, and I'm rather proud of myself actually. Once again, you should try this if you enjoy learning, because learning's where the knowledge is. Dun, dun, dun. Okay, so this is it. The next page, we're just going to learn about quadratic equations. We're going to learn a little bit more about what does this A do, what does this B do, what does this C do. Oh, before I forget, use your answer to find the vertex of the parabola. Let's just go ahead and do that. I was so happy that I got my quadratic equation. Use your answer to find the vertex of the quadratic formula. Okay. So let's decide how we're going to approach this vertex of the quadratic formula. There's two ways we can definitely go about doing it. I'm going to go back to the version where I set it equal to y, where it wasn't set equal to 0, but it was set equal to y. I'm going back up here. And I'm probably just going to combine these. So I have y equals a times x plus b divided by 2a squared. Okay. These were combined. So we would have plus, let's just see what it is, 4a squared c minus ab squared divided by 4a squared. I can factor out an a from this and have y equals a times x plus b over 2a squared. Plus, if I factor out an a, an a, an a, 4ac minus b squared over 4a. I cannot factor out a 4 because there's no 4 here. Okay. So technically the vertex form of this would be the opposite of this. The x value would be negative b over 2a. Yep. And then the y value would be something along the lines of whatever 4ac minus b squared divided by 4a. Let's just check. Yeah, 4ac minus b squared divided by 4a. I didn't have complete faith in myself. I just wanted to check to make sure my answer was good. And that's it. Generally, what we would do is we know that for the vertex, and again, the vertex of any quadratic is its max or min. The x value would be negative b over 2a. I would plug this in for all x's and then get my y out. And this will be whatever that y is. If you want a clear-cut formula, this is a formula as well. But if anything, plug this in for your x value, get your y out. And that's what we're going to do. I'll do one example just to so generally, let's say we have the equation y equals x minus 4 squared minus 64. Your vertex is positive 4, comma, negative 64, because we have to send this, oh, well, it's negative 64. Let's say, for instance, we didn't have that, I guess. Even though in this case we would have. If I plug in 4 here, it works out fine. 4 minus 4 is 0. 0 squared is negative 64. But let's say instead we started out with the original equation, y equals x squared minus 8x minus 48. In this case, we're going to plug in 4 for all the x values, and we're going to see that y eventually ends up as negative 64. Y equals 16 minus 32, 48. Good job. And our y version is negative 64. So once you have the x version, you can always plug it in. So now we're finally done. Hooray, we completed the square, we derived, we're learning the ins and outs of all this stuff. Thank you, Al-Khwarizmi. Now let's learn a bit more about quadratic equations in terms of what does this A, B, and C actually do. These are your actual equations, but I'm sure you have these. What you should be doing now for your own benefit, and this is what your quiz will be, you should go to Desmos graphing calculator. You can do this on your own if you want to, and just play around with these polynomials. This is a specific link. There's an actual Desmos calculator feature that lets you essentially automatically plugs in an equation like this and lets you change the A, B, and C. And your quiz will be, I want to know what changing A does to the quadratic, what changing B does, and what changing C does. And the solutions to this are also posted with this video in the Google Classroom. What happens as you increase even powers? What's the difference between x squared and x to the 8th? What's the difference what happens as you increase odd powers? What's the difference of x to the 1st power, Mr. Sneaky 1, and x to the 7th? Which is flatter in the window? Check for these answers. Try to do some thinking on your own. Check for these answers. I'm going to show you the Desmos graphing calculator app. Well, not quite the app, but essentially we're going to toy around and see what does happen when we're changing x and y. Okay. Here we go. Share it. Okay. So you essentially go to Desmos graphing calculator, hit this little button here, and I'm looking for parabola standard form. Yeah. If you notice, there's a bunch of conic sections and stuff here as well. It's very helpful. Let's select that and open the graph. And just looking at this equation, trial and error, brainstorm. Right now, A is 1, B is 0, and C is 1. Let's make B 1 and see what happens. Well, technically you can make it 1, but that's not supremely interesting. This is what happens as I'm changing B. I see like an inverted horseshoe going on. Remember our vertex form? Or for the vertex, it's negative B over 2A. So if this is the vertex, notice the influence B has on the vertex. So no wonder negative B over 2A is part of the equation. Notice wherever B has a large influence also as to whether or not there are imaginary roots or real roots. C has a lot as well. So again, and then A, if A is negative, we have 2 solutions. If A is positive, we have no solutions, no real number solutions, only 2 imaginary solutions. So we see what A does. So again, your quiz is to type out what does A do? And what does B do? Inverted horseshoe. What does C do? And the answers will be posted. Just for those that want to see without having to click on the link, I'm going to go ahead and show the answers now. Share. It's not really what I want. Oh well, I'll post the answers to the actual account, and you can look those up. Um, thank you. Goodbye.